Hey everybody, today we are going to learn more about parallel lines and transversals, as well as alternate interior angles, alternate exterior angles, consecutive interior angles, corresponding angles, all the different types of angle pairs we've learned about already. We're going to extend our knowledge on those a little bit today. So, the corresponding angles converse. If two lines are cut by a transversal, so the corresponding angles are congruent, I'm just going to use the symbol here, then the lines are parallel. Okay, so the corresponding angles postulate says that if lines are parallel, then corresponding angles are congruent. What converse means is you take the if part and the then part and switch them. Okay, so the converse is backwards. If two lines are cut by a transversal, so corresponding angles are congruent, then lines are parallel. So if angle 2 and angle 6 here are congruent, then line J is parallel to line K. So we are going to find the value of x that makes lines M and N parallel. So these are both in a top right position, so they are corresponding angles. If these lines are going to be parallel, then these two angles must be congruent. So I can set their measures equal to each other. 3x plus 5 is equal to 65. Okay, so when I subtract 5, I get 3x equals 60. And divide by 3, and I get x is 20. Okay, so 3 times 20 is 60. Plus 5 is 65. So if x is 20, then these lines are parallel. X can be anything in the world, but the lines aren't necessarily parallel. But these two lines are parallel only when x is 20. Is there enough information in the diagram to conclude that M and N are parallel lines? Okay. So I've got a 75 and a 105, but these aren't corresponding angles. So I'm going to have to say at this point, I'm not really sure, but if I could just find this measure right here. Now I've got a linear pair here. So I could do 180 minus 75. Okay, so 180 minus 75 is 105. So this right here is 105 degrees. Now, I see that these are congruent corresponding angles. So the answer is yes. Explain. So the reason I would say that these are parallel lines is the corresponding angles converse. Okay, because corresponding angles are congruent, which means the lines are parallel. So these are definitely parallel lines. Okay, explain why corresponding angles postulate is the converse of corresponding angles converse. And I already talked about that a little bit. It's because the if and then parts are switched. That's what a converse means. The if and then parts are switched. Okay? Now we are going to do the same thing for our other theorems that we learned in our last lesson. Alternate interior angles converse. So the alternate interior angles theorem said that if lines are parallel, then alternate interior angles are congruent. This starts with alternate interior angles are congruent. And if that's true, then lines are parallel. So here's a pair of alternate interior angles, and because they are congruent, I know these lines are parallel. Alternate exterior angle theorem told us that if lines are parallel, then alternate exterior angles are congruent. The converse of that says if we have alternate exterior angles that are congruent, then the lines are parallel. So here's a pair of alternate exterior angles that are congruent. That means the lines are parallel. And then the consecutive interior angles converse. The consecutive interior angles theorem told us that if consecutive interior angles are supplementary, then if the lines are parallel, then these angles, consecutive interior angles, are supplementary. The converse starts with, if the consecutive interior angles are supplementary, then the lines are parallel. So the measure of angles 3 and 5 here. So if the measure of angle 3 plus the measure of angle 5 is 180 degrees, then line J is parallel to line K. All right, how can you tell whether the sides of the pattern in this diamondback snake skin are parallel lines? Okay, so according to this picture, we've got these angles congruent. Okay, these are alternate interior angles. Okay, so if these angles are congruent, then these lines are parallel. Okay, so we can tell because alternate interior angles are congruent. Okay, and that is the alternate interior angles converse. Tells us if these alternate interior angles are congruent, then these lines must be parallel. All right, looks like my numbering system got a little messed up here, so we'll just pretend we're on 4 and then 5, 6. So can you prove that lines A and B are parallel? Why or why not? In this case, what I'm looking at is a pair of alternate exterior angles that are congruent, which means yes, line A is parallel to line B, and it's because of the alternate exterior angles converse. Here, both of these are in a bottom right position. These are corresponding angles, and they happen to be congruent. So, yes, line A is parallel to line B, and it's because of corresponding angles converse. Okay, here I know that angles 1 and 2 add up to 180. These are alternate interior angles. Well, alternate interior angles should be congruent. So I'm going to say I cannot prove that these are parallel lines because as far as I know, alternate interior angles are not congruent. Okay, on to example 3, and we're going to talk a little bit about parallel lines in particular. So there is a property called the transitive property, so I'm going to make a note here. The transitive property, and you may recall having learned this before. The transitive property says that if A equals B and B equals C, then A must equal C. Okay, because A and C are equal to the same thing, then A and C are equal to each other. That same thing applies to parallel lines. If a line is parallel to another line, and that other line is parallel to a third line, then the first and third lines must be parallel to each other. So here we're going to explain why, if each stripe is parallel to the stripe right below it, why is the top stripe parallel to the bottom stripe? So if the first stripe is parallel to the second stripe, and the second stripe is parallel to the third stripe, then the first and third must be parallel also. And if the third is parallel to the fourth, then the first and fourth must be parallel. And if the fourth is parallel to the fifth, then the first and fifth must be parallel. and it continues that way until we finally come to the conclusion that the top stripe must be parallel to the bottom stripe, and that is called the transitive property of parallel lines. All right, we're going to complete this paragraph using this diagram. Okay, so in this diagram, it is given that angles 4 and 5 are congruent to each other. And given that much information, we are going to prove the alternate interior angles converse. So we're going to prove that it must be true that since these are parallel, or these are congruent, that these lines are parallel. Okay, so 4 and 5 are congruent, and by the vertical angles theorem, angles 1 and 4 must be congruent. Because they are vertical angles, they are congruent. Okay? So that means if 4 and 5 are congruent, and 1 and 4 are congruent, then 1 and 5 must be congruent by the transitive property of congruence. So since 5 is congruent to 4 and 1 is congruent to 4, 1 and 5 must also be congruent. Okay? Now I've got corresponding angles that are congruent. So by the corresponding angles converse, I know that lines G and H are parallel to each other. So for our last question, if each step here is parallel to the one right above it, and the bottom step is parallel to the ground, how do I know that the top step is parallel to the ground? So if the top is parallel to the one beneath it, which we know from this first sentence, and the one beneath that is parallel to the third step down, then the first and third are parallel, and so on, and that goes all the way down to the ground, so every step is parallel to every other step, including the ground, based on the transitive property of parallel lines.